Hello friends, in today's question, a linear harmonic oscillator of force constant 2 into 10 to the power 6 Newton meter and amplitude 0.01 meter has a total mechanical energy of 160 joules. So we have to find out what will be maximum potential as well as kinetic energy. These are the different values, but in all the cases it is maximum potential energy as well as maximum kinetic energy. In this case, this is very interesting question. Let me draw first of all the basic, you can say SHM diagram which we usually use. So we have this as a mean position, that is x is equal to 0. So this is our mean position, and we have this our extreme position. Let us suppose this is x is equal to minus a, other extreme position x is equal to plus a. So if we go by only this, you can say a schematic, from here we can say that when at extreme position we have that the entire energy will be equal to potential energy, or we can say here potential energy will be maximum, and this point the kinetic energy is equal to 0. At the mean position the potential energy is equal to minimum and the kinetic energy is equal to maximum, and for the other side also we are going to have that potential energy is maximum and the kinetic energy here will be equal to 0. And in all the three positions the summation of the energy will be equal to total mechanical energy, and that will be always constant. Okay. So from here we can say that if total energy will be equal to potential energy plus kinetic energy, that will be constant. Here also total energy will be equal to potential energy plus kinetic energy, and that will be also equal to constant. And to the other extreme also we are going to have total energy is equal to kinetic energy plus potential energy, and that will be also equal to constant. So for one thing we are very sure that at the extreme end at least the kinetic energy will be equal to 0. Okay, for the extreme ends at least the kinetic energy is equal to 0. This we are very sure at the extreme, because the moment you can say the oscillations reaches the extreme position, it has to restore back to its mean position. So fraction of second the velocity becomes equal to 0. Okay, so therefore here the kinetic energy has to be equal to 0. Okay. Whereas in the mean position, in general what we study is that the potential energy is equal to 0. This is a normal understanding during the explanation and during the question also. But in practical situation it might be possible that at the mean position the potential energy becomes minimum. Okay, and no doubt the kinetic energy will be maximum. So summation of both potential energy minimum and kinetic energy maximum will also be once again equal to constant. So let's find out what will be the maximum kinetic energy. Okay. So we say maximum kinetic energy. We write this as Ke max, and which will be equal to half K amplitude square, and this will be 1 by 2. K is given as 2 into 10 to the power 6, and A is given as 10 to the power minus 2 and square. So we get this 2 and 2 goes away, this will be 10 to the power minus 4, and this will be 6. So we are going to get kinetic energy maximum will be equal to 100 joules. So we have that kinetic energy maximum will be equal to 100 joule. So at least this option is correct, and this is multi-correct option, so we are also going to verify other things. So we can say that option B is correct. Option B is correct. And like I said, the total energy will be always equal to constant. So we can say total energy, or in case total mechanical energy, is always constant. Therefore, we can write that total energy will be equal to kinetic energy plus potential energy, and we have the kinetic energy is over 100. So let us find out what will be our potential energy. And total energy is given as 160. So we can write this as 160 will be equal to 100 plus potential energy, and from here we get that potential energy will be equal to 60 joules. Okay. And in this case, if the kinetic energy is maximum, the potential energy has to be minimum. So let me write it here, that kinetic energy is maximum, potential energy is minimum, and this is a maximum and we have this as a minimum. So therefore we get potential energy minimum is our 60 joules. Okay, that option is not available to us, but we are going to keep it in mind. So next we are going to find out that what will be the maximum potential energy, because in the question it is only about the maximum. So we know that the maximum potential energy is only at the extreme position when x is equal to a. So you can say maximum potential energy is at x is equal to plus minus a, and at this position kinetic energy is equal to 0, and potential energy, like we said, is equal to potential energy maximum. Therefore, once again, the total energy is equal to kinetic energy plus potential energy, and at the extreme position potential energy is maximum, kinetic energy is our minimum, which in this case will be equal to 0. So we can write this will be equal to our 0 plus potential energy maximum, and total energy is 160 joules. So therefore we can write that potential energy maximum is equal to 160 joules. Okay. And we are given that potential energy maximum is our 160 joules. So we have option B as well as option C are the correct one. Therefore we can say that option C is correct. So finally we can say that option B and option C are correct. So this was a little bit tricky question, okay, but it's quite simple based on the simple concept of the SHM. Okay, so this completes the question. Thank you.